Hello everyone, I am Jubair ibn Mustafa. I am going to describe buffer overflow attack. First of all, let me start presentation mode. So before describing buffer overflow attack, I will go through some definition. What actually a buffer is. A buffer, also called buffer memory, is a portion of computer's memory that is set aside as a temporary holding place for data that is being sent to or received from an external device such as hard disk, keyboard or printer. What this actually means, suppose you have a memory, so there you allocated some space to hold some data temporarily, that can be comes from as input from keyboard or as output to printer or a data from your hard disk. So this if this is a system memory long and we allocate some space in our memory, this is called buffer. Next, buffer overflow. A buffer overflow or buffer overrun is an anomaly. This is not normally happened, so it calls as anomaly, where a program where writing data to a buffer overruns the buffer's boundary and overrides adjacent memory location. So if we think this is our buffer allocated space and we write some data into this address, but the data is used from our allocated space, then this overwrite our adjacent memory address. So this is gonna call buffer overflow. And what actually buffer overflow attack means? Buffer overflow attack is really corrupting or overwriting data held in adjacent space, and by taking control of memory, executing some malicious program is called buffer overflow attack. This actually means if you allocated some buffer in your memory and you overwrite adjacent spaces, here adjacent space, this address also hold some data. So then you overwrite those data, and if you refer to another location where the program will be executing and that is malicious, then you can attack in system memory. So this is called buffer overflow attack. Now we will go through memory overview. If you have a memory like this, so the process view as memory, it owns all of it, but in reality these are virtual addresses. There is no physical address like this, so it actually map when the program execute into physical memory. Now see this code. Here this is not our intention code to this is for just demonstration what memory addresses will be after executing this program. So here you see array with size, and it is globally declared, and total is also globally declared, and here you can see static integer x. So this all allocate memory from heap memory. There are two kinds of memory addresses like stack and heap. So this kind of declaration allocate memory from heap, and this you can see the main function, add function, and this sort of function and the local variable take address from stack memory. So this parameter like a, b, in temp, this all gonna load from stack memory. So here is the memory overview. You have this memory, and here text initial is here text like program command, and this is initialize data. If you initialize data like here we don't initialize anything, but if you initialize sum equal to 0, then in a function, then the initialized data will allocated this memory segment. Initialized data like static integer x. So this static variable or globally declared variable, if we declare some global variable, then it will initialize with 0. How this happened really actually happened. So this actually store in uninitialized data segment, and computer or system operating system itself declare with 0. And we see that malallocation memory size. So this gonna store data in heap, and from function local variable like something stack store data in stack memory. And this is command line environment where we execute the program, and this set in command line environment variable segment data. So this is the memory overview when we store a program in memory and execute. So here is some more elaborate meanings what this actually means. You can see stack runtime variable allocate memory in runtime with local variables, and heap dynamically allocated when needed like malloc, new, and data segment. This data segment statically allowed allocated data with global variable and text to executable instructions. Here you can say heap memory increase in upwards and stack memory increases in downwards, and they both are contradiction. Now we know our memory descriptions. So these are the short terms which will be used in buffer overflow attack, or to know what actually buffer, what actually memory addresses in buffer. ESP means stack pointer, where you actually this is a stack, and from here if a function is declared and function's data will start from stack position, and that is the stack pointer. And base pointer, ED means base pointer, and base pointer allocate means where the function base pointer actually located in, and instruction pointer means next instruction pointer, where program will next executed. So if we go back to our code, in main function, we call to the add functions. So add functions initialize variable or parameters will be allocated from stack, frame, and this base address will be where the memory called, and this return next instruction point in memory, this instructed to add, next instruction point is add. So it returns the value, and that will be base point return address. So here you can see the memory overview in stack. This actually in reverse form, like this actually upwards and store data from downwards. But to easily understand the things, here this scenario is in reverse order. So basically what will happen if we think like a program where user provides some input and this copy the user input into a memory size like 100. So this start input from stack pointer like a and this raises to all the memory addresses. So here you can see saved base pointer return addresses. So while the input is grown and we start copy from the user input to a buffer, this if the input size is within our buffer allocated size, then it will be okay. And if this overrun, like if you have 50 size memory addresses, but you write like 100 or 60, 64, then one time where your size is overwritten, then you actually overwrite your base pointer and return addresses where and next instruction point also. So what this gonna get? This gonna break your all machine instructions that is saved in your memory. So if you call a function from main and override, and that function returns some value, and if you overwrite your return addresses, so machine can't know what will be executed in next. So if you override the return addresses, base addresses, and denote some other malicious code into next instruction pointer, so memory will execute that code. So if malicious code in your next instruction point, so this will execute, and they attack your system with buffer overflow. So this is all. So we'll see a demonstration in our next tutorial. Thank you guys.